differentiation rules and rates of change. So the objective of 2.2, find the derivative of a function using the constant rule, and find the derivative of a function using the power rule, and find the derivative of a function using the constant multiple rule, find the derivative of a function using the sum and difference rules. And then we're going to find the derivative of sine functions and cosine functions, and find the derivative of rates of a change. Constant rule. Remember that constant is what? This is also derivative. Everybody remember this? Remember derivative, you can do many different ways. You can do f prime, dy dx, and you can do this. Everything same thing. So they were asking you what's the derivative of a number? Constant is a number, right? That means what? 0, because it's horizontal line. You're not changing y values. So y value 1 and y value 2 is what? Same number. So you get what do you get? 0 over whatever number is give you what? 0. That's why your sloping is a 0, constant. Everybody with me? So constant function, your derivative is what? 0. That's the easiest one. So if I give you f of x equal to 7, what is my f prime of x? 0. Did you see that? That's the beauty. Constant rule. They're saying any constant number, you take a derivative, you get what? 0. Can I do this then? F of x equal to 1,000. What's my f prime of x? Again, it's 0. It doesn't matter what x, what number. If it's a number, the derivative is what? 0. All right. Next one. Well, we got that one already. They gave you more examples. Every one of them is what? 0. Power rule. Power rule. Before proving the next rule, it is important to review the procedure for expanding of binomials. So when you expand this, does everybody agree that's what you get? Okay, remember this one, this is the same as what? Same thing. Right? This means what? 3 of the same thing, this means what? 4 of the binomials, this means what? 5 of the same binomials. So when you expand it, that's what you get. So using this, they found a pattern. What's the pattern? Okay, look at this. The general binomial expansion of a positive integer n is, you get this. All right, just a general form. That's a pattern they found. Now they said this binomial expansion is used proving a special case of the power rule. Okay, they wanted to show you this first and say, hey, I got this formula by what? Looking at this pattern. Are you with me, class? So you got this, looking at this pattern. Now, using that, this is what they found. They said, hey, so if you take derivative using the power rule, this is what I found. If you have something to the n power, or this is a power, you see it? That's what's called power rule. You have a power. What do? You bring down the power times what? The function, and then what happens to your power now? Subtract 1, you get one smaller power. So let's look at that. This problem. So I bring down what? 3 in the front. Now I have a what? X squared. Does it make sense? So power rule is also easy. Did you see that, class? If you use this using a limit definition to find the derivative, how long does it take? 5 minutes or more, right? At least 1 page. But look at this. 1 line, you're done. That's why giving this shortcut is very, what? Make your life easier for you. All right, so memorize your shortcuts. Next one. If I give this, what do I need to do first? Watch this, class. This is just third power rule. I need to rewrite this cubic root into what? Rewrite this problem as what? X to the what? 1/3. Is everybody with me? Remember this, your homework problem has this kind of problem. If you have a radicals, make it into what? Power, because we have a rule for power rule. We don't have a radical rule. So make the radical problem into what? Power rule. So what do you do now then? You bring out 1/3. How did you get negative 2/3? Right, because x to the what? 1 minus what? 1/3 minus 1. Right? That's the same as what? 1/3 minus 3/3, which is the same as what? 2/3. That's why you have x to the negative 2/3. Is everybody with me? All right, because I'm not going to do this one again and again, but I want you to remember this, how I get negative 2/3. Since it's a negative power, where do I need to put it? In the denominator to make it what? Positive power. So I put this into where? In the denominator. Is everybody following me? Is everybody with me right now? Okay. Any questions so far? Everybody good? Okay. Next. Again, this, I can use it, but this is in the wrong place, right? I need to be what? Something to the power rule, not in the denominator. So what do I need to do very first? X to the what power? Negative 2. So now, since it's this, that means we'll bring down the negative 2. 1 less power. Is everybody with me? And negative 2, 1 less power, what do you have? Negative 3. Are you with me, class? When you have a negative power, you get a what? More negative power. So since it's a negative power, what do you have to put? In the denominator. Does everybody see this negative came from? That negative 2. Is everybody with me now? So far, so good? Yes.
Is this PowerPoint on Blackboard?
Yes. So they're giving you the, what do you call it, strategies. If we have this, what you do, we write into what? Power. Proper power, so you know how to do that, use the power rule. Everybody see that? They give you step by step. Okay, constant multiple rule. Is everybody with me so far? So we so far learned constant rule, which is the easiest one, always 0, right? The power rule, what do you do? Bring down the power, and then what do you do? Take away 1 power. Now, constant multiple rule. So if I have a constant times this, let's look at this problem, right here. So what do I do? Look, this constant really doesn't matter. So what do I do? I multiply by what? 5 with what? 3. 5 with 3 give you what? 15. And then 3 power become a 1 less power. You get what? Second power. Is everybody with me? Are you following me? I feel like you're not following me. Because like, if you follow me, you do it like this. But today I see your hand is like stand still, not moving. That means you're not following me. All right. Okay, just watching me. If you have a y equal to 5x to the third. So y prime is what? You leave a 5. Don't worry about the 5. Just do the power rule. What your power rule says. Bring down 3, right? And then x to the what? 3 minus 1, right? Am I right? I'm not skipping any steps, so what do you have? 15 and x to the what? Square. That's it. So if you have a constant, what do? You just multiply that with what? Your power. That's it. So this is the same as power rule, but you just have a more other than 1 as your coefficient. That's it. So this is the same as a power rule. You just have a constant that's other than 1. Is this clear to you now? Mm-hmm. Okay. All right, I have this. The first thing first, what do I need to do? Rewrite this problem, right? 2 times what? X to the negative 1. Is everybody with me? Okay. If this is confusing, just look at this one now. Y prime is what? 2 times negative 1, right? Bring down negative 1 times x to the negative 1 minus 1. Okay, what do you have then? Negative 2, x to the negative 2. Since it's a negative, try to put it into where? Denominator. Does it make sense to you now? Okay. It's getting there. You gotta practice, class. This is easy, but if you don't practice, it's not gonna be easy, okay? Practice makes what? Perfect. Okay. Because I like to teach 2.2. That's my favorite thing. Because they give you easy rule, they just need to follow. All right, next one. Again, same thing. I have f of t equal to 4/5. Let's make it into what? T squared like that. Because I want to put the number separately with the variable. Okay, now what can I do? Then f prime of t is what? 4/5 times what? 2 t minus 1. So far so good? Okay, now what I have then? 4 times what? 2. This is same as over 1. Are you with me, class? The 2 goes with the what? Numerator. So we have 8/5 t to the 1 power. So you can write down like that, or you can write down what? 8t/5, whichever is fine. Are you following me, class? It's good? So far, so good. Next example. All right, what do we need to do? Same thing. Y equal to what? 2 to the x to the what power, class?
-1.
1 half,
Only 1/2.
right? 1/2. Because it's square root means what? Half power. All right, so then we're gonna do the same thing again. So y prime is what? 2 times 1/2 times x to what? 1/2 minus 1. What's that equal to that? Cancel out, so x to the what? -1/2. So where does it go to that? 1/1/2, which is the same as what? Square root of x. So far, so good, class? Okay, it's not hard. You already know everything. Remember, you know how to subtract fractions and all that. We did this practice problem. Remember your worksheets that you did? That's what I want you to do, because you're going to have a fraction, addition and subtractions. Okay, class, you got to practice, okay? It's easy, but if you don't practice, it's not that easy. All right, next one. I want to move this one to, I cannot, okay. How about I put the other part? So that's the E, we have y is equal to okay, this is what we have. So first thing first, I gotta rewrite this problem, am I right? So let's rewrite it. So y is equal to 1/2. 1/2, I'm gonna put the number by itself. What else you have? This is the same as what? X to the 2/3. I'm making this radical into a power first. But this is the denominator, so I need to put this, rewrite this one as what? 1/2, and then x to the what power? -2/3. Are you following me? Okay, now, can I use power rule? Yes. So you cannot use power rule right away. You have to make this into the form of the power rule that you can use. So now I can do power rule. Y prime is 1/2 times what? -2/3 times x to the -2/3 minus 1, which gives me 2 and 2 cancel out. You have -1, 1/3, x to the what? This gives you what? 5/3. Am I right, class? This is the same, really same means what? -2/3 minus -3/3, which is what? -5/3. Following me, class? Okay, so you're done, pretty much almost done. Now, since it's a negative power, I'm gonna put that into what? Denominator. Okay, so this is a power rule, but it's better ways. Well, put this into what? Radical. So what's my radical?
Cube root of.
I'm going to have a third power, right? I mean, to have a third and then x to the what power? 5. This is your power for x squared, and this is your what? Radical. So denominator gives you what kind of radical to use? 3, cubic root. And this fifth gives you what? What power of x? So if I give you this class, what's my radical looks like? My fifth radical, right? And x to what number? 7 power. Is everybody with me? Okay. So far, so good? Okay, practice this, okay? It's not hard, but you gotta practice.
Let me raise it.
Okay. Derivative of a sine and cosine functions. That's it. Derivative of sine is what? Cosine. What's the derivative of a cosine? Negative sign. Better memorize it. Are you with me, class? Okay, this is a sine function. Are you with me, class? Okay, look at this. What is my derivative from here to here? Let me use different color. What's my derivative going? From here to here, what is my derivative? Positive. Am I right, class? What's my derivative after pi over 2? Negative. And you have what? Keep negative. And then what happened over here? Positive. Am I right, class? So your slope is like this. This is so your other function. That's your cosine function. Because cosine says is what? From here to here is what? Positive number. From here to here is what? Negative number. And then what happened? You get positive number. So sine, derivative of sine is what? Cosine. So derivative of sine is they're asking you what is your slope at each point. That happens to be same as what? Cosine. So derivative of cosine is what? Same as which one? Negative sine. So memorize that so you can do your homework problem. So what's my derivative? So this is easy now then. So trigonometric functions is easy to do the derivative because you don't even have to do power rules or anything like that. You just what? Memorize. So what's the derivative of a sine? Cosine. So you have what? 2 times the what? Cosine. Because you have 2 in the front. All right, this one I can rewrite as 1 over sine x, right? What's the derivative of a sine again? Cosine. So this is the same. 1 over cosine x, or you can write it down as what? Cosine x over 2. They're either way is fine. Either way is fine. Is everybody good? Are you guys tired? All right, so you have 2 functions. So we're gonna take derivative of this, and then we're gonna take the derivative of what? This. All right, what is the derivative of x? It's x to the 1, right? So 1 times x to the what? 1 minus 1. Am I right, class? Are you following me? Which gives you what? 1 minus 1, this is x to the what? 0 power, what is that equal to? 1. So this just has simply what? 1. So the derivative of this is just simply what? 1. Are you following me, class? Yes. Okay. And derivative of cosine is what? Simply what? Negative sine x. Okay, class, I want you to make sure that you understand this. If I give you this, all right, remember you have what power? 1 power. So if you take a derivative of that, what do you get? 1 times x to the 1 minus 1, which is 1 times x to the 0, which is 1 times 1, which is same as what? 1, just the 1. So let's just make sure you understand. If I give you this, what is my derivative of that?
Is
Just what? 3. Because this is a linear equation. Linear equation, the coefficient of the x is your what? Slope. Remember that? I don't care about other numbers. But this gives you 0. The derivative, which is the slope, what's the slope over here, which is what? 3. Does it make sense to you? Okay. All right, cosine x, derivative of cosine x is what? Negative sine x. What's the derivative of sine x? Cosine, since you have a negative, you have to put what? Negative, and your constant is constant. Does it make sense? Okay.